All right, so we want to solve this system of equations using Gaussian elimination. First thing we should do is write this in its augmented matrix form. So we're going to take the coefficients here, right? So the coefficient of x is 1, the coefficient of y is -3, the coefficient of z is 1, and then we put the vertical line here to represent where the equal sign is, and then we'll put the 1 on the other side. Okay, so for the second equation here, we get 2, -1, -2, and a 2. And for the third equation, we get a 1, 2, -3, and -1, right? This is called the augmented matrix. So what we want to have happen is we want a 1 in the first row, first column, right? So we have that 1, right, which is good. We don't need to switch anything or do anything else here, right? So the next thing we want to have happen is we want to use this row 1, right? Use row operations, again, the 0 here and the 0 here, right? So remember, this is going to be two different row operations, right? So what we want to do then is we want to multiply row 1 by -2, right? So if you multiply the whole row by -2 and add it to row 2, notice that we're going to get a 0 here, which is what we want, right? Similarly, we want to get a 0 here as well, right? So if we multiply row 1 by -1 and then just add that to row 3, right, that should give us the 0 here that we want here, okay? Let's go ahead and do these operations, right? Remember, what row 1 is not going to change, okay? We just use operations on it to get zeros here. Okay, so if you multiply row 1 by -2, right, 1 times -2 is -2, plus that gives us a 0. Right, -3 times -2 is +6 minus 1. Right, -2 minus 2 gives us -4 here. And then a -2 plus 2 gives us a 0. And then when we want to multiply row 1 by -1 and add it here, -1 plus 1 gives us a 0. Right? This becomes a +3 plus 2. This becomes a -1 minus 3, which is -4. Okay. And then the -1 minus the 1 here is going to give us -2. Okay, so this is what we should end up with here once we do these first two row operations. Notice that we still have the 1 in the row, first column, but we have zeros underneath it now, right? Okay, the second thing, or the next, well, not the second, right, but the next thing we want to have happen is we want a 1 in the second row, second column, right? Remember, eventually we want to get 1s here along the main diagonal, okay? There's a couple things we can do here, but, let's just do it in the proper way. Let's multiply row 2 by 1/5, okay? So we'll take 1/5 row 2, okay? And that should give us the new row 2, of course, with a 1 in that diagonal spot here, right? So 0, 1, -4/5. Obviously, 0 times 1/5 just gives us a 0, okay? And everything else just stays the same. Okay? So now we want to get a 0 underneath this main diagonal 1 here, right? So we'll multiply, okay? We'll multiply row 2 by -5, add that to row 3. That should give us our new row 3, though, right? So let's do that here. We get a 1. I mean, row 1 doesn't change. Okay. Row 2 doesn't change as well. But notice what happens here, right? -1 times -5 is just a 5 here. Okay, so that -5 should give us a 0 here. Okay. And here's where it gets really interesting, right? -4/5 times -5 is +4, but when we add it here, we get a 0 actually, right? And -5 times 0 is just 0. We get a -2. Okay. Oh, wait a minute. What happened? We get a row of zeros with this -2, right? What does it mean, though? Okay. So what this bottom row means is that 0x plus 0y plus 0z equals -2. Okay. Now, well, wait a minute. If these are all zeros, but we're going to equal some non-zero number here, right? This can actually never happen, right? Mathematically, this can never happen. Okay, 0x plus 0y plus 0z, right? No matter what x and y and z are, right? It can never equal -2 because of the zeros here. So what does that mean then? What does that mean in relation to this original equation here, the system of equations? It means that there's no solution. Okay? So here, our final answer should be no solution. Remember, this is a 3 by 3 system of equations, right? So If you draw a three-variable equation, now it's going to be a plane, right? It's going to be like a flat plane, but there's going to be no place where these intersect. Okay, so this system has no solution.